Hello everybody, welcome to Mathscape Preet. Today I am taking exercise 8.1. Chapter name is Quadrilaterals of grade 9. Book is ncert. So the question number 1 of this exercise is asking us if the diagonals of a parallelogram are equal, then it is a rectangle that I have to show. So we have a parallelogram with equal diagonals. We have to show that it is forming a rectangle. So let's say if we have this parallelogram, try to draw it like a rectangle. So if this is my parallelogram ABCD, because at the end we have to show it is forming a rectangle, so it's better to take such figure that is similar to rectangle. So ABCD, this is my parallelogram, and it is given that the diagonals of this parallelogram are equal. So these are the diagonals AC and BD. So what we have, so I have to show that this is forming a rectangle. So if we know the definition of a rectangle, that a parallelogram is a rectangle only when angle at a vertex, at least one angle at a vertex, is of 90 degrees. So when one angle is 90, automatically other three will be of 90 degree through the properties. Now these two triangles, what is common here? AD is common to DA. So AD is equals to DA. What is this? Common side. So this is the side, common side, fine. What else? This AC is given equals to, AC is equals to DB. AC is equals to DB. Why? Because this is given to us. Fine. What else? This DC is equals to AB. DC is equals to AB according to the definition of this parallelogram. Why? Because ABCD is a parallelogram. This is the reason. So all three are sides that we have proved equal. Therefore, by SSS criteria, by SSS rule of congruence, you have to write complete. It's better to write it like by SSS rule of congruence. What we have, these two triangles congruent. Triangle ADC is congruent to triangle DAB. Fine. When we have these two triangles congruent, then what I have now? I have by CPCT this angle. This angle is equals to this angle. Fine. Angle ADC, write the complete name. ADC is equals to angle DAB. Fine. By CPCT. Now see in this diagram, when these two angles are equal, these two angles are equal now. Fine. Now we know that these are two parallel lines, AB and DC or CD are two parallel lines, and AD is intersecting as a transversal. As we will write, as AB is parallel to CD and AD is acting as a transversal, then what I am having, angle ADC plus angle DAB is equals to 180 degree. How? Sum of co-interior angles. Sum of co-interior angles is what? Always 180 degree. So now these two angles are equal. I can put the value DAB for ADC. So DAB plus DAB. You can mark it number 1. So here you can write from number 1. Okay. So this is equals to 180 degree. So what I am having now? 2 times of angle DAB is equals to 180 degree. So this is giving me angle DAB is equals to, I'll take this 2 down, so I'm getting 90 degree. So this angle is 90 degree, which means therefore angle ADC is also 90 degree. Fine. So we have proved that in this figure where two diagonals are equal and this side is equals to this side is equals to this side. So basically a parallelogram is given with equal diagonals. We have proved that this angle is 90, this angle is 90. We have just proved. So this is fulfilling the definition for a parallelogram to be a rectangle. Therefore, ABCD is forming a rectangle. So this is the proof or solution for the question number 1. This is question number 2. It's saying that show that the diagonals of a square are equal and bisect each other at right angles. So first we need to understand what the question is asking us to perform. So it's asking for 3 things. What is given to us? That we have a square, and we have to show that its diagonals are equal, first thing. Second, we have to show that they are bisecting each other, and third, we have to show that they are bisecting at 90 degrees. We have to show that first thing, to show, I'm writing to show. First thing that I have to show that this AC is equals to BD. Second thing that I have to show that they are bisecting. So if I am drawing these diagonals like this, and if they are intersecting at O, I have to show that these are bisecting. Bisecting means that this portion AO will be equals to CO, means they are intersecting at the midpoint. Okay, and what else? AO is equals to CO, BO is equals to DO. Third thing that I have to show that angle at this point of intersection are of 90 degree. Find any of the angles, say angle AOB is equals to 90 degree. This I have to show. So this is my DC. This is my DC, and this is point A. This is my first triangle. Second triangle is AB and D. So I'll draw AB here, AB, and this point D here. Okay. So these are two triangles I am taking to show that these are congruent. If these are congruent, if I somehow show that these are congruent, then I can show this is equals to this by simplicity. So let me write in triangle ADC and triangle, which triangle? DAB. So in these two triangles, what I am having, AD is equals to DA. You can write common side. So this is a side. Next is DC. DC is equals to AB. Why? Because this is a square. So opposite side of a pair of opposite sides of square. What else? If this was my triangle and this is my second triangle, here this angle will be equals to this angle of 90 degree according to the definition of the square. So angle ADC is equals to angle DAB is equals to 90 degree. Why? Because ABCD is a square. This is the reason. Now in these two triangles, I have proved this side is equals to this side is equals to this side, and the included angle. Therefore, this was also a side, this is an angle. Therefore, by side angle side. Why? Because angle is included. By this rule, these two triangles are what? Congruent now. These two triangles are congruent. Therefore, by CPCT, what I am having? I have to prove that this is equals to this. These two diagonals are equal. By CPCT, this third side will be equal. So AC will be equals to DB. AC will be equals to DB. So first part we have proved that diagonals of a square are equal. So this was the proof for the first part. The second part is asking me to show AO is equals to OC and BO is equals to OD. So this side is equals to this side is equals to this side. So what I will do, I will take these two triangles to show congruent. So first triangle I am taking D, C and O. Fine. Second triangle I am taking D, C and O. So here I will write B, A and O. DC, then BA. Fine. So let's write in triangle DCO and DOC, or DOC. It's better to write DOC. DOC and triangle BOA. Or other way, the common way to write in the generally in the books is COD and AOB. Fine. So you can write anyway, but the one correspondence should be correct. So in these two triangles, what I am having, DC is equals to BA, opposite sides of square. Second is this angle. This angle will be equals to this angle. How? These are two parallel lines. This is acting as a transversal, so this is making a pair of alternate interior angles which is equal. Why equal? Because the lines are parallel. So here angle DCO I am taking till here. Here you can also see DCO. DCO will be equals to OAB. DCO. So here I'll write BAO. BAO by pair of alternate interior angles or alternate angles. Fine. So this was a side, this was an angle. What else? This was side, this was angle. So if I show this angle is equals to this angle, then by angle side angle we have proved that these two triangles are congruent. So again the same thing, these are parallel lines, BD is a transversal, therefore this pair of alternate interior angles will be equal, and take the names till here, point O. So I am writing angle CDO will be equals to ABO with the same reason. Fine. So this is also an angle, therefore by side is included in both the angles. Therefore, by angle side angle rule, we have proved that these two triangles are congruent. DOC is congruent to BOE. When these two triangles are congruent, then by CPCT, I can write this side is equals to this side is equals to this side. Therefore, by CPCT, what I am having, DO is equals to BO and CO is equals to AO. This was the thing that I have to prove. AO is equals to CO or OC and DO is equals to BO. Therefore, by CPCT we have this result, hence proved. This was the proof that is showing that these diagonals are bisecting each other. So here you have to write in wording. What? Diagonals. Which diagonals? AC and DB are bisecting each other, hence proved. Fine. Try to write the language as it is given in the question. So let's see the proof for the part third, which is saying that these diagonals are bisecting, but bisecting at 90 degrees. Now I have to show that this angle is 90. If this is my 90, then by vertically opposite angle, this angle will be 90. If this is 90, then by linear angle sum property, I can show this is 90. If this angle is 90, then again by vertically opposite angle, I can show this angle is, fourth angle is of 90 degrees. So it is enough to show that any of the four angles is making 90 degree angle. I am taking angle AOB first. So if I have to show that angle AOB is of 90 degree, then I'll move in these two triangles to show them congruent. So I'm writing proof of this third part. Okay. So this is my first triangle that I am taking, OAB, and to show this is congruent to this triangle. So I'm taking O here and OA to this side. I will take CB here. Fine. So in triangle AOB and triangle COB, what I am having, OB is equals to OB common side. This is a side. Fine. What else? I have just proved in the second part that this side is equals to this side. Why? Because these are bisecting, but diagonals are bisecting each other. So AO will be equals to CO, proved in part number 2. Fine. What else I have AB and this. So it is a square, so all the four sides are equal, so CB will be equals to AB. So I am writing AB is equals to CB. Why? Because ABCD is a square. Here also all the four sides are equal because it is a square. Fine. So by side rule, what I have proved that AOB is equals to, a triangle AOB is congruent to triangle COB. This I have proved. Now when these two triangles are congruent, then by CPCT this angle will be equals to this angle. By CPCT, angle AOB will be equals to COB. Till here I hope every step is clear to you. Now it is clear from the figure that AC and this OB are making a linear pair of angles. So we can write angle AOB plus angle COB. This is equals to 180 degree. How? Linear pair of angles. So a linear pair of angles sum is always 180 degree. So but here AOB is equals to COB, so I can write this AOB as COB. So I am having two angles COB, 2 times angle COB is equals to 180 degree. Therefore angle COB is equals to 90 degree, which is further is equals to angle AOB. So I have proved that these two angles are what? 90 degree. Well, this is enough. So I have proved that these two angles are of 90 degree, which is enough to show that these diagonals are bisecting at right angles. So here you can write, therefore diagonals of a square AC and BD are bisecting at 90 degree, hence proved. So this was the proof for the third part. So I hope each and every step of these first two questions of this exercise are clear to you. I request you to share my videos with your friends and mates and subscribe for more such videos on mathematics. Thank you for watching. Have a good day.